Hi, today I am discussing the chapter polynomials, and the topic we are going to discuss here is factorization of algebraic expression. So, factorization of algebraic expression. Here, what we have done is, we have, before this, we have learnt about expansion of algebraic identities. So the expression given was a plus b whole square, and we were asked to expand it. And using the identity, we used to write it as a square plus 2ab plus b square. The factorization is the reverse of the expansion process. Here the expression will be a square plus 2ab plus b square, and the answer is a plus b whole square. So it is just the reverse of what we have learned. So let's understand with some examples. So before we do that, let's understand what are the identities which will be used for factorization. The first identity is a square plus 2ab plus b square is a plus b whole square. So that is the first identity. So if you see here, everything is positive, so you will get a plus b. Now see the minus one. A square minus 2ab plus b square. Answer is a minus b whole square. So the middle term decides whether it will be negative or positive. Okay, because the first and the last term is always positive in both the cases. Next one, a square minus b square. It is a plus b, a minus b. Okay, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Here it is a plus b plus c whole square. That means, see, when you have the squares of three terms, then it is a plus b plus c whole square. So that's how you understand. If you get a question where we are having squares of three terms, then this is the identity to be used. Next, a raised to 3 plus b raised to 3 plus 3ab into a plus b. That's equal to a plus b whole cube. Okay, cubes of two terms. Cube of the first term and the cube of the second term, and all terms are positive, then it is a plus b whole cube. Okay. If all terms are negative and it's a cube of two terms, that is a raised to 3 minus b raised to 3 minus 3ab times a minus b, then it is a minus b whole cube. Okay. Now the same things here. A raised to 3 plus b raised to 3. Here, this identity has been derived from this previous identity. This positive term, when you shift it to the right side, it becomes negative. So it is a plus b whole cube minus 3ab into a plus b. So it is the sum of the cubes of two terms, a raised to 3 plus b raised to 3. Okay. Similarly, for this identity, we shift this term to this side and you get a raised to 3 minus b raised to 3 is equal to a minus b whole cube plus 3ab into a plus b. This negative term goes to the right side and it becomes positive. Now, this could also be written as a raised to 3 plus b raised to 3 could also be written as, now you see here, a plus b, a plus b. So we can take out a plus b common. And once you take out the thing and little simplify, you get a square minus ab plus b square. So a raised to 3 plus b raised to 3 could also be written in this form. Similarly, for a raised to 3 minus b raised to 3, a minus b is taken out as common and you get a minus b, a square plus ab plus b square. So if it is minus, the first bracket is minus. If it is plus, the first bracket is plus, and the middle term all are positive. A raised to 3 plus b raised to 3 plus c raised to 3 minus 3abc. It is equal to a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. Here, these last three terms, they don't have 2, so you cannot say it is equal to this. Okay, it is square of three terms minus ab minus bc minus ca. So this is a raised to 3 plus b raised to 3 plus c raised to 3 minus 3abc is given by this. Suppose this a plus b plus c is 0. If this becomes 0, then 0 into this entire bracket will become 0. So that means a raised to 3 plus b raised to 3 plus c raised to minus 3abc will be 0. You can bring this one this side and it will become if a plus b plus c is 0, then a raised to 3 plus b raised to 3 plus c raised to 3 is equal to 3abc. These were the identities which will be useful for solving the problems. Now let us start with examples. An illustrate example. Let us take one example. So factorization can be done by using the identities. So we learned or by splitting the middle term. So factorization can be done by two methods, that is by using the identities or by splitting the middle term. So let us consider examples to understand which method is to be used by looking at the expression given. Okay. So look at the expression to decide which method will be suited to us. So I'll take a single example and try to solve with both the methods and you'll see how it affects and what is the method. So let us take one example. So let us factorize one particular thing. 4x square plus 12x plus 9. This is the polynomial to be factorized. So now here you see in this expression, the coefficient of x square, that is, coefficient of this term is 4, and the constant term is 9. And okay, 4 and 9 are both perfect squares, so identity method can be used. Okay, so first step will be whether you have to see whether the first term and the last term are perfect squares. If they are perfect squares, then the identity can be used. Okay, then now let us see this, how to do it. Now, because they are perfect squares, then it will be a square plus 2ab plus b square, which is equal to a plus b whole square. Now, comparing the identities with the given expression, we get that we compare this 4x square. That means it is a square of 2x. 2x whole square is 4x square. That means our a term is 2x. This term is 9. It is a square of 3. That means b is 3. So we substitute a has 2x and b has 3 in this particular expansion. So you see here 4x square plus 12x square is equal to 2x whole square plus 2 into 2x into 3, that is 2ab, plus b square, that is 3 square. Okay. Now let us see whether we get the middle term. 3 2s are 6, 6 2s are 12, 12x, 12x, yes. We are getting the middle term. So this is a perfect thing. So your answer will be 2x plus 3 whole square. Yeah. So the middle term which you multiply, you should get the middle term. Multiply the first term and the last term into 2. If you get the middle term, that means the identity is perfect and we can use it and just write the answer as 2x plus 3. Now let us take the same example and solve it using the splitting the middle term method so that we get a comparative study of the two. Factorizes. So now we factorize the same expression using the splitting the middle term. In this above expression, the coefficient of x square is 4 and the constant term is 9. 4 and 9 are to be multiplied, that is 36. Okay. So here what we do is we first multiply the 4 and 9. The coefficient of x square and the constant term should be multiplied. We get 36. We now find the factors of 36. Okay, find the factors of such that if you multiply, we should get 36, and if you add the factors, we should get the middle term 12. Okay, so whether you should add or subtract, this sign before the constant term will decide. The sign before the constant term will decide if we have to add or subtract to get the middle term. So now we take the factors of 36. 1 into 36 is 36. Let us add the two factors. 1 and 36 is 37. 2 into 18 is 36. 2 plus 18 is 20. 3 12s are 36. 3 plus 12 is 15. 4 9s are 36. 4 into 9 is 4 plus 9 is 13. 6 6 are 36. 6 plus 6 is 12. Now, in our question, we need 12. So we select the 6 plus 6 is equal to 12, this as a factor. And these all are of not used to us for this particular question. So 4 into 9 is 36. Therefore, we split the middle term, that is 12, as 6 plus 6. So 4x square plus 6x plus 6x plus 9. Now take the first two terms and take out common. Common is 2x, bracket what you are left with 2x plus 3. The next two terms, the common term is 3, 3 bracket 2x plus 3. Now if you see this entire expression, 2x plus 3 you have here, 2x plus 3 you have here also. So take it out. Once you take it out, in the second bracket, outside the first bracket you have got 2x, write it in the first term. And outside the second bracket, you have got plus 3, right? Plus 3 there. So 2x plus 3, 2x plus 3. This 2x plus 3, 2x plus 3 is written 2 times. Therefore, you can write it as 2x plus 3 whole square. So if you see here, here also you get the same answer here. So irrespective of which method you follow, you will get the same answer. Okay. Now, I'll consider one more example. Now, see here, 4x square plus 15 plus 9. Now, the same first term and the last term is same. First term is same, last term is same. The middle term has changed. And the middle term has changed. Now see here, the above example, 4 and 9 are perfect squares. So, but identity method cannot be used. While here, 4x square, that is 2x square, that is a is 2x. And 9, that is 3 square, that is b is equal to 3. But the middle term of the identity is 2ab, that is 2 into 2x into 3, that is 2 2s are 4, 4 3s are 12, 12x. Middle term should be 12x, but the middle term in my question is 15x. So the identity method has a restriction. So splitting the middle term method works, except when the roots are not real, we get complex roots, which you will learn in the higher classes. Otherwise, this splitting the middle term method works for almost every type of sum. Now let us see this. So let us factorize this above polynomial. The last term is positive, so we must add the factors to get the middle term. Which is the last term? This is the last term. It's having plus sign in front of it. Therefore, we must add it to get the middle term. Now see here. Again, we did what we did previously. 1 into 36 is 36. 1 plus 6 is 37. We want 15, so this doesn't go. 2 18s are 36. 2 plus 18 is 20. Again, not possible. 3 into 12 is 36. 3 plus 12 is 15. It's correct. 4 nines are 36. 4 plus 9 is 13. No, it doesn't work. 6 6 are 36. 6 plus 6 is 12. So for us, the factors which we need is 3 and 12. So 36, the middle term will split it have 4x square plus 12x plus 3x. So 15 can be written as 12x plus 3x plus 9. Take common from these two terms. So common will be 4x. This is x plus 3 plus 3 bracket x plus 3. Right, x plus 3. So outside this bracket you got 4x, right? 4x. Outside the second bracket you got plus 3, right? Plus 3. So the factors are x plus 3, 4x plus 3. So the splitting the middle term is much more convenient and useful. We need not think whether it will be suiting the particular identity, which identity will be suited. So here we can directly go in for splitting the middle term and it works out very well. The last term, now see this is the last term. Suppose this is negative. If this is negative, you must subtract the factors to get the middle term. Okay? If the last term is negative, you should subtract the factors to get the middle term. So let us consider the example. 4x square minus 36, 35x minus 9. Again, we do the same thing. And I want 35 by subtracting the factors. So the first factor is 1 into 36 is 36. 1 minus 36 is minus 35. I want minus 35. So this will be the factors which you will have to split it up. So middle term I'm going to split it as minus 36 plus 1x minus 9. Take out common. 4x is common. X minus 9 plus 1 into x minus 9. So it is x minus 9, 4x plus 1. So when this last sign will decide whether you have to add the factors to get the middle term or subtract the factors to get the middle term. I think I'm clear that when to add the factors to get the middle term and when to subtract the factors to get the middle term. So I am purposely have been using the same expression, only changing the middle term, so that you get a clear idea. We are able to compare the terms and try to decide which is the thing. Now let us take some more examples. Now see how. First one. 25x square minus 20 plus 4. Here, by identity method, if it is going, you are going to use it, then it is a square minus 2ab plus b square. And it should be a minus b whole square. So if you see 25, 25 is a perfect square. So this could be written as 5x whole square. 4 is a perfect square. It can be written as 2 square. Then if these are the a and b, then your middle term should be 2 into these two terms. That is 2 into 5x into 2. 2 5s are 10, 10 2s are 20. Yes, it's working out very well. So our answer should be a minus b whole square. That is 5x minus 2 whole square. Okay, identity. Now, suppose this 4x square, same sum. Now by splitting the middle term. Now what are we getting here? The first number and the last number should be multiplied. 25 into 4 is 100. And 100 can be written as 10 tens are 100. And if you add these two, 10 plus 10 is 20. But I want minus 20, so you should take minus 10 minus 10, so that you'll get minus 20. So split the middle term as, write the first term as it is. Split the middle term as minus 10x plus 4. Take common from the first two terms. You're getting 5x as the common. So 5 5 is 23. So 5x minus 2. Here again common. 2 is common. 5x minus 2. So 5x minus 2, 5x minus 2 will become 5x minus 2 whole square. Okay. Now see this. 5x square minus 14x plus 8. 5 and 8 are not perfect squares. So only splitting the middle term method can be used. So 5 eights are 40. Okay. 5 eights are 40. Now we got 40. You have to find the factors of 40. If you add, you should get 14. Factors of 40 can be written as 4 tens are 40. And 4 plus 10 is 14. Okay. So that means our splitting term, middle terms must be 10 and 4. And we want minus 14. So we have to write minus 10 minus 4. So that you get minus 14. Now split the middle term 5x square minus 10x minus 4x plus 8. Take out common 5x, x minus 2. Take out common 4, x minus 2. So it is 5x minus 4 and x minus 2. This is the answer. Okay. So when the numbers are not perfect squares, first and the last terms, splitting middle term works out. The identity method does not work. See this. 6x square minus 25x minus 14. Now, 6 and 14 are not perfect squares. So, splitting the middle term method only can be used. 6 into 14 is 84. Okay. And 84, if I subtract factors, I must get 25. What are the factors? 28 into 3 is 84. And I want minus 25. So I put minus 28 plus 3. So I'll give you minus 25. So I write 6x square minus 28x plus 3x minus 14. Now from this 2, if I take out common, 2x is common, 2x minus 14, and here there is nothing common, so I just write 1 bracket 3x minus 14. So 3x minus 14, in the other bracket 2x plus 1, 2x plus 1. Okay, so this was splitting. So I'm just giving more examples so that you understand the concept and how to use it. Because when you try on your own, you will need to know the method exactly when to use and how to use it. Now see this. Now we are using an identity here. Now if you see here, here this one has got square, square, square. Three terms are squares. And as I told you while talking about the identities, I told you if there are three squares, then the identity which will work out is a square plus b square plus c square minus 2ab minus 2bc 2ca equal to a minus b plus c whole square. Okay. Now, here you have to see these two. These two terms are negative. In these two terms which are negative, which is the letter common to both? Q is common. Q is common means the middle, this term, Q term is negative. So you will write this as 2p whole square. This have to be written minus 3q whole square. And this is 4r whole square minus 2pq minus 2 into the first term into second term minus the second term into the third term plus 2 into the third term into the first term. So your A, B, C is this. So it is 2P minus 3Q plus 4R whole square. Okay, so this is the expansion of identity, and this identity is possible only if the squares of three terms are given. Okay, now some more examples, illustrative examples. Because we have got a number of identities, so that's why I'm taking more and examples on identities because we need to know how to use the identity. Splitting of middle term works out only for three terms, quadratic equation. Now see here, 25p square plus 36q square plus 49r square plus 30pq minus 42qr minus 35rp. Here again, we are using the identity a square plus b square plus c square plus 2ab minus 2bc minus 2ca. So here these two terms are negative. The letter common to both these terms is R. That means your third term is this term is negative term. Okay, that's how you have to decide. Now, so 5p whole square plus 36q whole square is a mistake here. Minus sign should have been here. 7r whole square plus 2 into 5p into 6q minus 2 into 6q into 7r minus 2 into 7r into 5p. So here the first term is 5p, second term is 6q, and third term is minus 7r whole square. This is the expansion. Okay, so this is the factors of this polynomial. Now, now see this 9x minus 2y whole square minus 4 into x minus 2y minus 13. So here you see this looks a little rather complicated. So what we do, in this place of x minus 2y, I write it as a. So let us take a is equal to x minus 2y. When you take a is equal to x minus 2y, so this first, the given polynomial takes this form 9a square minus 4a minus 13. Now let us try to split this, splitting the middle term, let us try to solve this. 9 into 13. 9 into 13 is 117. And if you subtract, I must get 4. And 13 minus 9 is 4 only. But I want minus 4, so I put bigger number minus and smaller number plus. Minus 13 plus 4, that is minus 4. So split the middle term, 9a square minus 13a plus 9a minus 13. Take common from these two. There's 9 and 13 has no common factor. So only a is common. Take out a. 9a minus 13. Here again there is nothing common. So take out 1 and use it 9a minus 13. So this will 9a minus 13 and a plus 1. Okay. Now we have factorized this polynomial, but our question is different. So I'll have to put back the value of a. So what happens? Here 9 into x minus 2y. So it becomes 9x minus 18y minus 13. And here it is x minus 2y plus 1, putting back the value of a. So when certain questions are slightly complicated, you need to slightly modify it and bring it in the quadratic form and then solve it. And it becomes as usual, we solve the splitting middle term and works out very well. Now see this. 4 root 3 x square plus 5x minus 2 root 3. Now, the splitting middle term has to be used here. So, the first term is 4 root 3. The last term is 2 root 3. So, you need to multiply these two. 4 root 3 into 2 root 3. When you are multiplying, this is our irrational numbers. So, when you are multiplying irrational numbers, real number with real number and root with root. Okay. So 4 into 2 and root 3 into root 3. 4 2s are 8, root 3 into root 3 is 3. So 8 3s are 24. Therefore, now you have to find the factors of 24. If you subtract, I must get 5. 8 3s are 24 and 8 minus 3 is 5. So this itself is the factor. So write the first term as it is. Now, second middle term, you break it as plus 8x minus 3x minus 2 root 3. Now, common from these two is 4x. So, it is root 3 because x and 4 2s are 8. So, 8 and x is outside. Here, 3 can be written as root 3 into root 3. 1 root 3, you take it out. And 1 root 3 will remain inside root 3x plus 2. So, your answer will be root 3x plus 2. And the second bracket will have 4x minus root 3. 4x minus root 3. This will be your question. Okay. So, that will be the answer. Now, a raised to 3 minus 27. A raised to 3 minus b 27 means with the identity method, it is a raised to 3 minus b raised to 3. And the answer will be a minus b, a square minus a square plus ab plus b square. So here this one a raised to 3 and 27 you can write in as 3 raised to 3. So your first a term is a and b term is 3. So your answer will be a minus b, that is a minus 3. And this is a square, that is a square minus 3 into a plus 3 square is 9. Here again there's a mistake, please correct it. It is a square, it has come out to be 3. So mistake there, please. I'm sorry for that. Now see here, 27 a raised to 3 plus 125 b raised to 3. Now a plus b whole cube, we can use this second and another identity here. A raised to 3 plus b raised to a plus b whole cube minus 3ab into a plus b. Okay. Now, so I have showed you when discussing the identities, I have discussed this identity also, this identity also. So I'm using one identity for the one method and other one so that you know how to use both the identities. The 27 is the cube of 3. So it is 27a cube is 3a cube. 125 is the cube of 5. So 5b whole cube. So your a is 3a and b is 5b. So as per this, it should be 3a plus 5b whole cube minus 3 into 3a into 5b into times 3a plus 5b. 3a plus 5b whole cube, 3 3s are 9, 9 5s are 45, 45ab bracket 3a plus 5b. So 3a plus 5b whole cube, 45 3s are 135 it is a into a square, b. Okay, and minus plus is minus. So 45 5s are 225 a b square. So this will be your answer. So now you see here a raised to 3 plus b raised to 3. We got A minus B, A square plus AB plus B square. Or it could also be this way. A square minus B square is A minus B. So note these two ones. Say this one and this one. A minus B, A raised to 3 minus B raised to 3. It could be written like this, or it could also be written this way. Or A raised to 3 plus B raised to 3 could be written this way, or it could also be written this way. So note these two identities. They are so just that's why I've taken these two examples so you get a clear idea how this. So these are little special. Two answers you got for the same thing. This is also correct, and this is also correct. Okay, so that's why keep in mind. It's not necessary. Sometimes in the backside answer of your textbook, if they give a particular answer, not necessary that suppose you have taken this answer identity and the backside answer is in this form, need not worry. It's your thing is correct. That's why I have just to compare it. I just put the both the thing together. Now, some other examples. Now, a raised to 3 plus b raised to 3 plus c raised to 3 minus 3abc. So the identity is a plus b plus c, a square plus b square plus c square minus ab minus bc minus c. So that means this first term is a cube of something. So 8 is a cube of 2. So 2p whole cube. 27 is a cube of 3. It is 3q whole cube. 8. And r, there's only r, there's no number associated with it. So it is r cube minus 3abc. 3abc is what? 3 into first term is 2p, second term is 3q, third term is r. So 3 into 2p into 3q plus r. So now you see, let us see. 3 2s are 6, 6 3s are 18, 18 PQR, 18 PQRS. It works out very correctly. So as per this identity, our thing should be 2p plus 3q plus r, 2p square plus 3q square plus r square minus first and second term, that is 2p into 3q minus second and third term, 3q into r minus third and first term. Okay, so this is, it becomes this first bracket as it is. This becomes 4p square plus 9q square plus r square. 3 2s are 6pq minus 3qr minus 2pr. Okay, now see this. Now the question is a little complicated. We are just making it a little more tougher so that you understand that sums are not always easy types. You can ask little difficult ones also. So here it's already in the form of cubes. This is a cube plus b cube plus c cube minus 3abc. So this should be your answer. So as per this, so what it will be? Your first bracket should be a plus b plus c. So that is p plus q plus r plus p. Second bracket will be square of the first term plus square of the second plus square of the third plus, so minus first term into second term, that is this into this, then minus second term into the first term minus first term into the last term, third term. So the first bracket you see here, P, P, there are two P's here. Q, Q, there are two Q's here. R, R, there are two R. So in first bracket, this becomes 2P plus 2Q plus 2R. And here a plus b whole square, you have to use it. So if you use that, it becomes e square plus 2pq plus q square. Here again a plus b whole square, that is q square plus 2qr plus r square. Here again same thing, r square plus 2rp plus p square. Now multiply these two. P into q is pq. P into r is pr. Q into q is q square. Q into r is qr. Minus sign. Again these two. Q into R is QR. Q into P is QP. R into R, R square. R into P, RP. Minus. Again multiply. P into R is PR. P into P, P square. Q into R, QR. Q into P, QP. Okay, so this is first bracket 2p plus 2q plus 2r. Now you see, when you open this second bracket, p square is here. Okay, you have a p square here, you have a p square here, bring them together. And you have one minus q square. Minus, because of this minus, because minus p square. Then q square minus r square, r square minus r square. Then 2pq. 2pq is here. Again, pq is here minus pq, minus pq. Okay, so 2pq minus pq minus pq. Okay, minus pq. Similarly, qr, 2qr, qr, qr, qr. 2rp, rp, rp, rp. So here what has happened? So this and this cancels, only one p square remains. This and this cancels, only one q square remains. This and this cancels, only one r square remains. And here, if you see this two, 2pq minus 3pq is only 1pq, so minus pq. Here also, 2qr minus 3qr is minus qr, minus qr. Here again, 2rp minus 3rp is only rp. So here this takes this form. We can take out 2 common from the first bracket, 2 bracket p plus q plus r, p square minus q square plus r square, minus pq minus qr minus r square. But if you see this, what is this? This is an identity exactly, isn't it? So that means it is p raised to 3 plus q raised to 3 plus r raised to 3 minus 3pqr. So see this exactly like this. PQR, P square plus Q square plus R square minus PQ minus QR minus RP. Exactly the identity. That means this bracket, these two together should be in this form. So that means this is 2 times this. Okay. So I expect you to practice it on your own. Write it down in the paper and try it on your own. You'll get a more understand. Unless you do it, I just spelling it out and reading it for you doesn't work out. You please try it on your own. Things will work out clearly. Now, one more. Now, see this factorize. Again, this is a little difficult type, different type, x square minus 4x, x square minus 4x minus 1 minus 20. So it is slightly different. Now see, it is neither in any of the identity forms. So how to do this? What I do, x square minus 4x, you write it down as it is. Here, see, again you got x square. So let us take this in a bracket, minus 1, minus 20. So when you do this, so you see here, so what happens? When you multiply this with this, it becomes x square minus 4x whole square. And x square minus 4x into 1 will be x square minus 4x minus 20. Clear now? Okay, what I did, I just taken this in a bracket and multiplied this with this. When you multiply the same thing, it is 2 times, therefore it becomes square. And this when you multiply with 1, it becomes x square minus 4x minus 20. Now if you see this, don't you get some idea? You can substitute this thing for something and solve it. You see, if I write, if I put x square minus 4x as y, then this will become y square minus y minus 20. Looks easy now. So now thing has become easier for us. Split the middle term. 5 4s are 20 minus 5a plus 4y minus 20. Take common from here. Y is common here. Okay, take common from these two. Take common from these two. Take out common, it becomes y minus 5. Take out 4, 4, y minus 5. Y minus 5 into y minus 5 into y plus 4. Now, this is factor. Now, let's put back this in this form. In place of y, let us write y square minus 4x. So it becomes y square minus 4x minus 5, y square minus 4x plus 4, resubstituting the value of y. Now again you have got two quadratics. Again splitting the middle term for this bracket and splitting the middle term for this bracket. See, 5. 5 ones are 5. 5 minus 1 is 4. So it is minus 5x plus 4. 1x. Here, 4. 2, you have to add. 2 twos are 4. So minus 2x minus 2x. Take common from these two, you see. X is common, so x minus 5. Nothing is common, so 1 into x minus 5. Here, 2, only x is common, x minus 2. And 2 is common, x minus 2. So it is x minus 5, x plus 1. And it is x minus 2 and x minus 2. So you can write it as, because this is 2 times, x minus 5, x plus 1 and x minus 2 whole square. Yeah. So if the sum is slightly different, see what can be done, how to substitute and convert it into a quadratic form. Once you get it into quadratic form, splitting the middle term works out very finely. This is, I think we'll have one more example so that you get, see this, x a square minus b square whole cube, b square minus c square whole cube, plus c square minus a square whole cube upon a minus b whole cube, b minus c whole cube, and c minus a whole cube. Okay. So a square minus b square minus c square, and c square minus a square. You see what is this? A square minus a square cancels. B square plus b square cancels. Minus c square plus c square. Everything. So that means a plus b plus c is 0. If a plus b plus c is 0, so using identity, if a plus b plus c is 0, then a raised to 3 plus b raised to 3 plus c raised to 3 must be 3 into a into b into c. So the numerator takes the form. So that is a square minus b square raised to 3. This becomes 3 into a square minus b square minus c square, and c square minus a square, 3abc. Okay. Now, a square minus b square cube plus this becomes 3. Now, a square minus b square is a plus b, a minus b. This is b square minus c square, b plus c, c b minus c. And this is c plus a, c minus b. So, the numerator takes this form. This is your numerator. Now, let us consider the denominator. Now, denominator, a minus b, b minus c, c minus c. So here again a minus a cancels, b minus b cancels, c minus c cancels. This is also 0. So again the same identity. So if you use the same identity, it is, this should be equal to 3 into a minus b, b minus c, c minus a. So this is your first numerator, this is your denominator. Let us write them one below the other. When you write below the other, see this is the taken the form. So 3 and 3 can cancel. A minus b cancels. B minus c cancels. C minus a cancels. And you will be left with a, b, a plus b, b plus c, and c minus c plus a. Okay. So you need to just see where it is. Okay? So thank you for watching and stay tuned for more such sums. Hope you have understood and you are confident enough to solve any type of quadratic this thing. If you are, have any doubt, you can call on this number or WhatsApp me your doubt. I'll definitely take care of and try to help you out in the things. Okay.